Hey there, everybody. We're almost at the end of our class. We're just going to take a moment to review the two types of division and unpack what these equations look like when we think about them as multiplication problems. That helps me think about where the unknown is, and it helps me keep it straight. So I'm going to share that with you. All right. So if we think about two types of division and we think about the problems that we just saw Emma solve, we saw that Miss Adams has 85 markers. If 10 markers fit in a box, how many boxes can Miss Adams fill? So if we think about the boxes as a number of groups, we know the product or the total is 85. We know that there are 10 in each group, but we don't know the number of groups. That's measurement division. When we think about the jelly bean problem, there are 52 jelly beans in a bag. 10 children want to share them so they each get the same amount. How many jelly beans would each child get? We know how many groups or children there are. There are 10. And we know how many jelly beans there are. There are 52. What we're looking for is the number of jelly beans in each group, the number of parts in each group. That's called partitive division. I like to think about it in terms of a multiplication equation and where does that unknown shift. So if we think of A as the number of groups and B as the parts in each group and C is the total product, when we think about multiplication, the product is the unknown. When we think about measurement division, the groups are unknown. And when we think about partitive division, the number of parts in each group is unknown. This may help you or it may not. It helps me, and so I wanted to share it with you. And why is this important? Because when we look at the framework, we start to see on page 89, there's a discussion in the framework about the different types of divisions. So there are multiplication problems where the product is unknown. And then there are the partitive division problems where we have equal groups. We have array problems or area problems, and then comparing problems. And we also have measurement division where we are looking for the how many groups. Okay, so when we are spending time talking about this, it's not just because it's something for 565M. It's actually in the mathematics education of our young people. We need to be aware as teachers about the difference of these types of problem structures. So let's take a moment now to look at some problems and see if we can unpack the type of problem that it is. Okay, so the Earth makes 1/12 of a rotation each month. How many rotations does the Earth make in 54 months? Do we know how many groups there are? The groups are the months. There are 54 months. And in each month or the part, it is 1/12 of a rotation. Okay, so this is a multiplication problem. Let's look at another one. 90 players signed up for the soccer league. If there are 8 teams, how many players can be on each team so that each team has the same amount of players? Do we know the total? Yes, 90 players. Do we know the number of groups? Yes, the teams. Do we know the number of parts in each group? No. So this is partitive division because we're looking for the number of parts or the number of players for each team. Jacob wants to buy fidget spinners for his friends. He has $35 to spend. If the fidget spinners cost $8 each, how many friends can he get fidget spinners for? So this is now a little bit tricky the way this is worded. But let's think. Do we know the number of dollars that Jacob has to spend? And we know that each spinner costs $8. And what we're looking for is how many friends he can get fidget spinners for. Okay, with the $35. So do we know the number of groups? No. So this is measurement division. All right. This also comes up in the context of the Smarter Balanced Assessment Consortium's SBAC assessment. So this is lifted right out of the sample items. Jamal's mother plans a trip for the baseball team. There are 14 players on the team. 5 parents are going on a trip. The players and parents will all travel together. Each car holds a total of 5 people. There must be at least one parent in each car. What is the fewest number of cars they need? Measurement division. Here we see it again in a fraction. equation. So this is, again, now we're talking about 4th or 5th grade here, but 4 divided by 1/8 equals. And so this is important when we have students work on number sense and reasoning routines where they're asking a question and creating the context themselves. So what is the solution here? Is it Jack has 4 pieces of fabric? Each piece is 1/8 of a yard long. How many yards of fabric does Jack have? Or Jack has 4 pieces of fabric. He gets 1/8 more yards of fabric. How many yards of fabric does Jack have now? Jack has 4 yards of fabric. He gives away 1/8 of his pieces of fabric. How many pieces of fabric does Jack have left? So B is addition. C is subtraction. And A um, is multiplication, but it doesn't match the problem. Let's look at D. Jack has 4 yards of fabric. He cuts the fabric into pieces 1/8 of a yard long. How many pieces of fabric does Jack have? So here again, we see measurement division surfacing in the SBAC. All right, so we're going to stop there, and I will talk to you about this next video.